Welcome. In this video, we're going to find the acceleration of the system and the tension in the cable that connects two blocks. So now the question says, consider the diagram below and answer the questions that follow. So we have this mass, which is on this surface, which is connected to this mass by this cable. So we're going to find the acceleration of the system as well as the tension in cable. So the information that we've been given mass 1, which is 5 kg, and mass 2, which is 3 kg. Now, find the value of acceleration and the tension in the cable. So this is the question that we're going to consider. Assume to say the motion is in this direction, moving like. So the first thing is to come up with a free body diagram. For free body diagram, let us come up with the first one, which is for mass 1. So we have the tension in this direction. Then we also have the normal force in this direction, and also the weight, which is simply mg. Okay, then since if we assume to say the motion is in this direction, so there is an opposing force right in this direction, which is the friction force. So this is for M1. This is for M1. Then we have for M2. So since it is like this, it's coming like this. So if this is the M1, then this is the M2. This is M2. And this is the tension. So if it is moving in this direction now, so we have the mg here, which is the weight for this. Now, the next thing is we need to find, or rather, we need to apply Newton's second law of motion. So Newton's second law of motion, for this one, we know that the summation of forces in y must give us ma, that is in y. Now, since we do not have any movement in this direction, so acceleration in the y direction is equal to 0. So the summation of forces here in y is going to give us 0. So in y here we have the n, then minus mg, which is pointing downwards here. This must give us 0. And this one is going to give us mg when it crosses the equal sign. So from here we can proceed to summation of forces in x. So here we have the summation of forces in x must give us ma x. Since the motion is assumed to be going in this direction, so acceleration has got some value. So here we have the forces, we have the t here, we have t, and we have the opposing motion in an opposite direction, which is the friction force, and this must give us so since it is it is m1, so we are going to have m1a. So from this we know that the coefficient of friction, or the coefficient of kinetic friction, or any other, but we know that coefficient of friction is given by the Fr, the friction force, over the normal force. But from this, we know that, so Fr is going to give us mu n. But from this, we know that n is equal to mg. So Fr is equal to mu mg. So if we replace Fr by this, we're going to have t minus mu mg is equal to, so this one, it is actually mu1 mg is equal to m1a. So this one, we can call this as equation number 1. So from here, we can proceed. So for M2, the summation of forces in Y must give us MA in Y. Since there's a motion that is coming like this, we have here the mg minus. So since these are in opposite direction, we're going to subtract. So minus t. This must give us m2. So this is m2g. M2g minus t must give us m2a. And this one, let us call it as equation number 2. So from here, what we're going to do is we're going to add these equations. So we add equations 1 and 2. So we have on the left side, we have m2. Okay, so 1. On the left side, we have t minus mu m1g. Then on this one on the left, we have plus m2g minus t. And on the right, here we have m1a. And here we have m2a. So from here, we're going to collect the like terms. So we're going to have t minus t. Then here we have plus m2g minus mu m1g. This must give us, so here since a is common, we can even factor it out. We're going to have a m1 plus m2. So from here, we see that this and this will cancel. And what we're going to have is m2g minus mu m1g, which must give us a m1 plus m2. So from here, we see that g is common. So we can even factor it out. G, then we have the m2 here minus mu m1. This must give us a m1 plus m2. And since we are looking for acceleration, we are trying to find the acceleration in the system. What we're going to do from here is we're going to make it the subject of the formula by simply dividing m1, m2, even here, m1 plus m2, so that this and this will go, and what we're going to have is our a, which will give us g m2 minus mu m1 over m1 plus m2. Now, plugging in the values, we can even write it as a is equal to g times, or we open the brackets, then we have the m2 minus the mu, which is coefficient of kinetic friction. We can even put a subscript k here, then m1 over m1 plus m2. We need a visible line here. Okay. If we plug in the values now, 9.8, the value for acceleration due to gravity or gravitational field strength. Then we have the m2, which is 3 kg minus 0.4, the coefficient of kinetic friction, times M1, which is 5 kg, over, we have 5 kg plus 3 kg. So here we're going to have 9.8 times this one will be 3 minus 2 over 8. So we're going to have, this is just 1 times 9.8, we're going to have 9.8 divided by 8. Punching this on a calculator, we are going to have 1.22 meters per second squared. Therefore, the value for acceleration is 1.22 meters per second squared. So this is the value. Now, using using one of the equations that we derived, we can find the tension. So if we make T the subject, this one is going to cross the equal sign. We're going to have T is equal to M1A plus, since it is negative here, when it crosses the equal sign, it is going to be a positive one. So we're going to have mu M1G, in fact, it is the coefficient of kinetic friction. When we plug, let us plug in the values now. So we have 5, that is 5 kg, times the acceleration is 1.22 plus, here we have the mu we have 0.4 times m1, which is mass 1 times 5, times 9.8. Punch this on a calculator, we are going to have 25.7 newtons. Therefore, the tension in the cable is 25.7 newtons. And this is the value. Thank you.